Right, so here's a question on inclined planes that includes friction. So we've got an inclined plane. Right angle triangle. Okay. Now it's inclined at an angle of 10 degrees. Okay, we've got a car that's moving down, okay, and that weighs 2,150 kilos. Okay, there's a constant driving force of 700 newtons, so that's pulling our car forward parallel to the plane. And then there's any friction between the road and tyres is initially ignored. That's the important part, initially ignored. Okay, and air resistance is modeled as a single constant force of magnitude F. So this is going in the opposite direction, and it's the air that's slowing it down here rather than the friction of the tyres in the first part of the question. So F newtons. Okay, so let's tackle part A. Given the car is traveling in a straight line at constant speed, again, as we said, as soon as you see constant speed, that means that A equals 0. Okay, right, so we can go up the slope because F is going up the slope. So as I said before, it was always a good idea to resolve in a positive direction at the force you're looking for. So then you get a positive answer. So we've got F, that's going up. Now what have we got? We've got minus the 700, which is acting in the opposite direction parallel. So that's the forces included in total. And then we've got 2,150, but that's not, remember this is our gravity vector. So that's 2,150 g, and we're going to multiply that by sine of 10, because remember, if our normal is in this direction, then that's our vertical plane, and then this angle is also 10 degrees. And we're doing this to the horizontal plane, so it's sine of 10. Okay, right, so now that is all equal to 0 because acceleration is 0. So that means that F equals 700 plus 2,150 g times sine of 10. And we put that in a calculator, we get 4,358.7 newtons. Great, okay. That's part A taken care of. Right now, the driver applies the brake suddenly. In the subsequent motion, the car continues to travel in a straight line and the car skid along the road. Okay, so you can imagine that means that basically if you apply the brakes, the engine, that driving force, the 700 newtons, is now gone. Okay, I'm bringing the car to a standstill after 40 meters. So the only force acting on, well, the only two forces acting on the car are the air resistance and the friction between the tyres and the road. Now, initially we ignored it, but now we're not going to, because that's the only thing, plus the air resistance, that's stopping the car. And the air resistance is modeled as remaining constant. Okay, so B. Well, now there's friction. Okay, we need to work out what R is. So our reaction force is equal to 2,150 G, but multiplied by cos 10, because remember, there's an angle to the vertical, no other forces, okay, because everything else is parallel to the plane. So if we work that out, we get 20,750 newtons. Okay, so now we've got that. So now we have to start thinking, this is going to be a SUVAT calculation because we've got the speed and it's slowing down. We've got to try and use that. So let's do our SUVAT thing. So S, yes, we know that's 40 meters. U, yeah, it's initially traveling at 22 meters per second. What's V? Well, it comes to a halt, so V is 0. So V is 0, sorry. A, don't know. T, Don't know. So what we want to know what the acceleration is, because then we can use F equals ma. Okay, so let's do that. So if we're going to put this into a calculation, we know that v squared is u squared plus 2as. I've got s, u, v, and I want a. So let's substitute them in. 0 squared equals 22 squared plus 2 lots of a times our s, which is 40. Okay, so if we rearrange all of that, we'll find that a is equal to minus 6.05. So now we can resolve up the plane. Remember, because this has changed from part A, because the situation has changed. Okay, so now what's acting upwards? We've got F, that's our force, minus the friction, plus the friction, same direction, minus gravity, which is pulling it down the slope. Sorry, like that. And then we're going to multiply that by sine 10, because again, we're acting in the horizontal. And that is equal to the mass 2150 times A. So now we know lots of these already. Well, we worked out what the force was. Force was 435870. So that's going to be 4358.7. We're going to add mu times R. Well, mu times R, which we calculated, that was 20,750 here. So mu times 2750 times oh, bless me. Sine of 10. Okay, and that is equal to 2150 times 6.05. Okay, so remember, when we worked out acceleration, that was basically moving down. It's negative, so that means acceleration is actually positive in this direction. So again, remember, it's really, 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 really important. Okay, the car was moving down, and acceleration was negative. Positive in the other direction. Okay, deceleration is negative acceleration. Okay, so we've got all of this. The only thing we don't know is what mu is. So we've got to basically rearrange this to get mu. Okay, so we're going to get mu is equal to 13,007.5 minus 700. Okay, and we divide that by 20,750, and that gives us 0.593, and that's our coefficient. And remember, the coefficient is something we're multiplying by, and it tells us whether basically we're getting the full frictional force or not. So this is always going to be a decimal. 1 is going to be the maximum. Okay, so now the last thing we're left with is part C, the state 1 limitations model used for air resistance. Okay, so as the car speed changes, okay, the air resistance would change. Okay, because actually, to calculate air resistance, it's actually the square of the speed you're moving, so it wouldn't be a constant. So that's a limitation of